To watch these important lessons, subscribe to DP Education's YouTube channel right now. Click on the bell icon to stay updated on the latest lessons. Sri Lanka's largest free online school, DP Education.
Hello my dear students, welcome to today's lesson. Today also I am going to continue with you all the O-Level 2020 paper, that is paper 2 part B. I am going to start the 8th question. So here question number 8 part A. A student recorded as follows 3 animals and features of 2 animals indicated as P and Q as their names were unknown to him, found in an okra or bandaka or vendi cultivation. So that is okra means bandaka or vendi cultivation. There he has found, the student has found these particular organisms. So here you can see a snail, a lizard, then there is a greater cockle, that is Eticukula or Chanpaham. And then there is the animal P, which has a thin, long and vermiform body, and the body is divided into equal segments. So I am sure looking at these characteristics, you can relate it to a type of organism. When something has a long, thin, vermiform body with segmentation, you all can relate it to an annelid worm. Then Q, it bears jointed legs and wings. So obviously when there are jointed legs, that means it is an arthropod. Arthropoda means jointed legs. And if it has wings, under arthropods there are insects. So I am sure you all can identify these two, P and Q. P as an annelid worm and Q as an arthropod insect. Then write answers to the following questions related to the animals observed. So the first question, A part, name the 2 vertebrate animals. Now to identify the vertebrate animals, you all know students, snail, what is it? It is a mollusk. Mollusk. Normally if you are writing the phylum, mollusca, otherwise we can write it as mollusk. Then lizard is a reptile that you can see. Now reptile is a vertebrate, whereas mollusk is an invertebrate. Then greater cockle is a bird. So there you can see bird. Then here we said this one is an annelid worm. Annelid worm. And this is an insect which belongs to Arthropoda. So out of all these, now mollusca, Annelida and Arthropoda, they are all invertebrate groups. Now reptiles or reptilia as well as aves, that is birds come under aves. Both of them, they are vertebrates. So here name the 2 vertebrate animals. What are they? It is the lizard, and we have the greater cockle. Greater cockle. Is that clear, students? So you identify the animals, you identify their group, and then you can relate them to whether they are vertebrates or invertebrates. And you all know why they are classified in that manner. Now mollusca, Annelida, Arthropoda, those animals do not have a backbone or a vertebral column. That is why they come under invertebrates. So under invertebrates, you all can remember students, there is the Echinodermata, Annelida, Arthropoda, mollusca and the Coelenterata. So those are the groups belonging to invertebrates. And under vertebrates, we have fishes, then we have amphibians, then reptiles, birds as well as mammals. So those are the groups under vertebrates. So you are familiar with that classification of kingdom Animalia. Then if I move on to the next one, what is the main characteristic on which the inclusion of those animals in the vertebrate group based? So how did we put them there? Due to the presence of a vertebral column, or you can say backbone. So there due to the presence of a vertebral column or you can say backbone. Vertebral column and backbone refer to the same thing. So that is how we group them as vertebrates. I'm sure you all can understand that. So with that, the next question. So here also I have put the same animals so that it's easy for us to answer the question. Snail, lizard, greater cockle. Then P, we identified it as an annelid worm, and Q, it is an insect. The second question, according to the above observations, what is the animal phylum to which P belongs to? So P, we identified it as an annelid worm. So if they ask for the phylum, what is the phylum? It is phylum Annelida. Phylum Annelida. So earlier I wrote it as annelid worm. So because I was just referring to the organism. But here since they have asked for the phylum, I have written it as phylum Annelida, or you can also just write it as Annelida. The word phylum is not a compulsory term there. You have to write this correctly. Annelida. Is that clear? So here you can see has a thin, long and vermiform body. You all know the meaning of vermiform body. Normally, if it is a long vermiform body. I have the diagrams in the next slide. So with that also I will explain it to you all. Then it becomes an annelid worm. Here I have put some examples here. You can see the thin, long vermiform body with the segmentation. So that is an annelid worm. Here also external appearance of an annelid, but it belongs to phylum Annelida. So here you can see these segmentations. They are internally and externally segmented. Is that clear? So here you can see the examples. You can see here an earthworm, a leech and a nereis. So all of them have both internal and external segmentation. So that's why we call them as segmented worms. Is that clear? So they all belong to phylum Annelida. The same way the organism also belongs to phylum Annelida. So with that, I'll move on to the next question. So again, I have the animals given there. The third question, state another common characteristic specified to the animal species of the phylum to which Q belongs. Now Q, we already identified it as Arthropoda. Arthropoda. How did we find that? Bears jointed legs. Arthro means jointed, poda means legs. So jointed legs means it's Arthropoda. There are so many different animals, but here this particular Arthropoda bears jointed legs and wings. So as an example, in the next slide, I have the diagram of an external appearance of an insect. So here you can see these are jointed legs. You can see the joint here, here, like that. You can see the jointed legs. Then you can see the wings there. Then what are the other features do you see here? Now, if it is an insect, you can see they have the antenna, the head, then thorax, abdomen, all that is seen. Now, what are these parts? The head, thorax, abdomen, what do we call them? They are known as stigma. How does this stigma form? Now, even arthropods are segmented animals. Their body is segmented, but what happens is 2, 3 or a few segments join together and form the stigma. So, this process is known as stigmatization. Now, when stigmatization happens, you get the head, then you get the thorax and the abdominal region. In addition to jointed limbs and the wings. So, that is another common feature of the organisms belonging to Arthropoda. not insecta, arthropoda. Now here, if you look at the question, you can see here, students, state another common characteristic specific to the animal species of the phylum to which Q belongs to. So they are asking the phylum to which Q belongs to. So you don't consider the insects, you consider the arthropods as a whole. So there, you can remember, in addition to insects, there are the crabs, prawns, spiders, scorpion, all of them belong to arthropods. So what is the common character? One thing I told you, the stegmatization. Another special feature is the chitin exoskeleton. Now, these wings and even the skeleton, it is made up of chitin. It is made up of chitin, the chitin exoskeleton. So that is another common property. Even the crab, prawn, spider, all of them, they contain this chitin exoskeleton. So those two are common characteristics. So that is what we need to write here. One thing we can say, possess a chitin exoskeleton. So you can say possess a chitin exoskeleton, or you can say presence of chitin exoskeleton. That is one feature. So although they have asked, state another common characteristics, like I always do, I'll write both the possible characters. You can write any one of them. And the second one, the body is composed of segments. Segments 2 or 3 or few segments combine and form stegma. This can be called as stegmatization. So you can write one of the two. You can say possess a chitin exoskeleton or covered by a chitin exoskeleton or presence of chitin exoskeleton. And the other one, the body is composed of segments, 2 or 3 or few segments combine and form stegma, which process is known as stegmatization. So that is a common character for phylum Arthropoda. Not only for insects, but a common character for Arthropoda. You can't write these jointed legs because that is already there. Is that clear, students? So with that, I'll move on to the next question. So again, I have put the animals here. Then the fourth one, state a favorable effect and an unfavorable effect which can be expected to have caused by Q on the crop. Now, Q is an insect. Here, you need to consider insects because they have said caused by Q on the crops. You have to write both favorable as well as unfavorable effects. So first we will write the favorable effects. Favorable effects. Effects. Now what are the favorable effects you can think of? Now insects in the crop, you all know when there are crops, there is sexual reproduction. During sexual reproduction, there is pollination occurring. And insects are an agent of pollination. So that is one favorable effect. They contribute for pollination. That is, insects are agents of pollination. Then you all can remember, students, now some insects act as pests. So there they come under unfavorable effects. At the same time, there are other insects that can be used to control pests. So that is a favorable effect. Helps to control pests. So if they contribute for pest control, what type of pest control is this? It is biological pest control. Biological pest control. So I have written 3 favorable effects. Another favorable effect you can think of is that normally these insects, they can actually go into the soil. They can dig through the soil. Although they are tiny, there are insects that dig through the soil. So then what happens? They loosen the soil. So when that happens, there is more air in the soil. So soil gets aerated. That is also another favorable effect that you can write here. So we can say loosen the soil, or you can say aerates the soil. So when the soil becomes loose and also it gets aerated, what can you say? The texture of the soil will vary. So that also can be written. Changes the texture of soil. So all these relate to the same thing. You can write any one of the answers. Loosen the soil, aerates the soil, or changes the texture of the soil. So that is one favorable effect. Like that I have written 4 favorable effects. They contribute for pollination, or they are agents of pollination, act as agents of pollination, then help to control pests. They act as biological pest control. Then they loosen the soil, aerates the soil, or changes the texture of the soil. So those are the favorable effects of these insects. Now you need to write one of these favorable effects. At the same time, we need to write the unfavorable effects also. Unfavorable effects. Unfavorable effects. Already I told you all one unfavorable effect. What is that? They act as pests. They act as pests. Now, the insect itself feeds on the plant, the crop. So then they become a pest. Then another thing, you all know, these particular insects act as vectors of diseases, disease-causing pathogens. That means they spread the disease, they spread the pathogens. So they involve in spreading the disease. Spreading the disease. So here we can say they are vectors of pathogens. You all know what vectors are. Vectors are organisms that carry the pathogen from one organism to another. So here they can spread the disease among crops. Then another thing that they do is that they feed on the fruits, leaves and flowers of crops. So because of that, they destroy the leaves, fruits and flowers, because they eat or consume them. So you can say they feed on leaves, fruits and flowers. Because of that, they destroy the leaves, fruits and flowers. And another thing, some of these insects actually feed on the roots of crops. So because of that, they destroy the roots of crops. So here, destroy the roots of crops. So here also, students, I have written 4 different unfavorable effects. You can write any one of them. One is they act as pest. Then the other thing, they cause or they spread diseases, actually not cause. They spread the disease, and also they destroy the leaves, fruits and flowers of plants, and they destroy the roots of crops. So you can write any one favorable effect and one unfavorable effect. Is that clear, student? So with that, I'll move on to the next question. Again, the same animals are given to you. Fifth one, state a primary consumer and a secondary consumer respectively in a food chain that contains animals observed in the okra cultivation. Now here, if you take a food chain. Now, how do we have the food chain? You can remember, students, initially it is going to be the producer. Then from the producer, it is the primary consumer. Primary consumer, usually the primary consumer is a herbivore. Usually, it doesn't have to be always, but normally it is a herbivore. Then we have the secondary consumer. Secondary consumer. And finally, we can have tertiary consumers. And usually, you all know a food chain with 3 to 4 links is a very efficient food chain. You can even have 5, but as the number of links increases, the energy obtained by the higher trophic level decreases. So, because of that, it is not very efficient. You all know about energy dissipation. When energy is transferred from one trophic level to the other, there is energy, about 90% energy is lost due to the growth, development as well as excretion, metabolic processes of the organism. About 90% of the energy is dissipated. So, because of that, the next trophic level only gets 10% of the energy. So, therefore, food chains with 4 links or 3 links is very efficient. More than that is usually not very efficient. So, here producer, then primary consumer, secondary consumer, tertiary consumer. Primary is usually a herbivore. Secondary, it can be a carnivore or an omnivore. And tertiary is usually a carnivore. But omnivores, you all know, they eat all the types of food. So, they can eat the plants as well as they can feed on animals. So, they can actually come in all 3 levels. The 3 levels of consumers. You are familiar with that. So, here, if we consider the animals given to us, you can see snail. Snail feeds on crops. So, it's a herbivore. So, that will come under primary consumer. Then, how about lizard? Lizards are usually, they feed on insects. So, they will actually come under secondary consumers. Because insects can feed on plants, then lizards can feed on insects. Then greater cockle, a bird that also usually feeds on insects. So, that also can become a secondary consumer. So, here then we have the annelid worm and the arthropod insect. Insects also can consume the plants, but here since they have asked for primary consumers and secondary consumers respectively in a food chain that contains animals observed in the okra cultivation. So, we will stick to the other organisms, snail, lizard and greater cockle. So, there, if we write the primary consumer, we can write snail. Then secondary consumer can be either a lizard or you can write greater cockle. Greater cockle. So you can write one of the two. Now primary consumer you need to write the snail, and secondary consumer it can be a lizard or a greater cockle. So you can have a food chain where you have the crop, snail and greater cockle. That is also possible. Or the crop, then you can have the snail and the lizard, something like that. So that is a food chain. Is that clear, students? So you have to use the animals given here only. You cannot use any other animals because they have said food chain that contains animals observed in the okra cultivation. So those are observed here. You cannot write any other animals. Is that clear? So you have to be careful when answering the questions. Read the question carefully and answer the question. Is that okay? So with that, I'll move on to the next question. The sixth one. A newspaper has printed greater cockle's scientific name as Centropus sinensis. According to the rules of binomial nomenclature, state two errors seen in it. So you're familiar with the binomial nomenclature? Who introduced binomial nomenclature? Carolus Linnaeus. So when we say binomial, there are two epithets for the scientific name of each organism. First epithet is the generic epithet. Second one is the specific epithet. So Centropus is generic, sinensis is specific. And when you print it, normally the first letter of the generic epithet has to be capital. The rest of the letters have to be simple. So here you can see one mistake. The specific epithet, the first letter has been printed in capital. So that is incorrect. The other thing is when you print it, the letters have to be italicized. But here the letters are normal letters. So that is also another mistake. You have to write both of them. They have asked two errors in it. So one thing we can say, the first letter of the specific epithet has been printed in capital, or we can say only the first letter of the generic epithet that should be capital letter. So the first letter of the specific epithet has been printed in capital letter, or you can say only the first letter of the generic epithet should be capital letter. Is that clear? That is one. Then the second one, we can say when printed, letters should be italicized. Or you can say the letters are normal letters. So one thing you have to say, it has to be italicized, or you can say that they have printed it in normal letters. So either way you can write. These are the two errors that you can observe, you can write them in any method. Is that clear, students? So with that, I'll move on to the next question. This is B part. Now, so far we discussed the A part of the 8th question. You saw it was a biology related question. But now it is the B part. If you read the question, a cylindrical water tank is kept on the roof of a 2-storied house. You all know this is a physics related question. So when I explained the paper format, I told you all there are questions where different parts of science, that is either biology, physics or chemistry, can be combined together as different parts of the question. So this is one such question. So a cylindrical water tank is kept on the roof of a 2-storied house. First one, consider an occasion in which 2 identical water taps in the upper floor and the ground floor of the house are kept fully open at the same time. So what happens here? We have a tank on the 2nd story. Then there is a tap in the 1st floor of the house, and also we have a tap on the 2nd floor of the house. So there are 2 taps. So this is the ground floor. Then this is the 1st story, and that is the 2nd story where you have the tank. Now what is the difference there? If you consider the height from the tank to the 1st floor and the height from the tank to the ground floor, you can obviously see as you go down, the height increases. So what will vary? Normally we have the tank at a higher elevation so that the pressure will be greater or the potential energy will be greater, so that it is easy for the water to flow down. It will flow down with a higher pressure. And that also, since this is on the 2nd floor, the tap on the 1st floor, there will be a certain amount of pressure. The tap on the ground floor, there will be a certain amount of pressure, but this pressure will be greater. Why? Because the height changes. That is why we normally have the tank on the top floor. Is that clear, students? Otherwise, if you have the tank on the bottom floor, you will have to pump it with higher pressure to send it to the upper floors. So when you have it at the upper floor, it's easy for the water to flow down. Another thing, when the height increases, the potential energy increases. Is that clear? So here you have to remember, as you come down, pressure increases because of the height. At the same time, when you consider the height, this way when you go up, what happens? Potential energy increases. So that is what happens here. You can see that, students. You all can understand the concept. Normally when we have the tank up, one thing, at the higher elevation, potential energy of the water is high. So there also it's easy for the water to flow down with a higher force, higher energy or higher pressure. At the same time, when this distance changes from the top floor where you have the tank, as you go down, the pressure of water increases because pressure depends on height of the water column. So because of that, the pressure increases. Is that clear, students? So this is what you can get, the idea you can get from the information given to us. Then, if we look at the questions. Consider an occasion in which 2 identical water taps in the upper floor and the ground floor of the house are kept fully open at the same time. A part, from the tap in which floor does water flow out with higher speed? So, which floor? The ground floor. Why? The pressure of water is higher. So, there we can say ground floor. It is the ground floor. So here, of course, in the question you can see they have given it as upper flow and the ground flow. So we can write it as ground flow, or you can write it as lower flow. That is also fine. Lower flow. Both are okay. Then B part, give the reason for your answer. So I have explained the reasons. So here you have to write one of the reasons. You can say, when the distance, or you can say height, between the tank and the tap increases, the pressure of water pressure of water increases. In brackets we can say liquid pressure depends on the height of liquid column. So that is one way you can explain this. When the distance or height between the tank and the tap increases, the pressure of water increases. So because of that, the ground flow tap, the water flows out with a higher pressure. Or else we can say, when the height of tank increases, the potential energy of water increases. So the height difference between the ground flow and the tank is higher compared to the tank and the upper flow. So because of that also the potential energy of water is higher. Because of that water flows out with a higher pressure. We can write this as well. So in this answer here what we can do is, we have said when the distance or height between the tank and the tap increases, the pressure of water increases. Here you can also mention it as hydrostatic pressure. I will write that also as another answer, but you can write any one of the three answers. The hydrostatic pressure depends, or we can say increases with increase in height of the tank from the tap. The first one and the third answer, they are similar. Only thing here I have used the word hydrostatic pressure. So we have here, I have written it as pressure. Either answer is fine. So you can relate it to pressure and height. You all know H rho G, pressure is H rho G. So there, when the height increases or the distance between the tank and the tap increases, the water column is longer, so the height is more, therefore the pressure is more. Or we can say when the height of the tank is higher, the potential energy of water is higher, so because of that also it flows out with a higher pressure. Or else you can say about the hydrostatic pressure. Is that clear, students? So here also you need to write only one explanation. You don't have to write all three. Any one of the explanation is correct. So with that, I'll move on to the next question. Second one, the inner cross-sectional area of the tank is 1 meter square and its height is 1 meter. Density of water is 1000 kilogram per meter cube and acceleration due to gravity is 10 meters per second. So here they have given some information. You can draw that here. If I just show it as in the diagram. Here they have given the height of the tank and the cross-sectional area. So this cross-sectional area is 1 meter squared and the height is also 1 meter. And the density of water is given. Here water density rho is equal to 1000 kilogram per meter cube and the gravitational acceleration 10 meters per second square. All that is given to us. This is the information. Then, what is the mass of water in the tank when it is completely filled with water? So, what is the equation for mass? So, here we need to find the mass of water that is contained in this tank. So, here they have given us the dimensions, the height and the cross-sectional area. So, you can find the volume of water that is present inside the tank. If you know the volume of water, then what we can do is we can relate it to density and then you can find the mass of water because density is the mass of unit volume of a particular substance. So, here volume of water is equal to what? 1 meter squared into 1 meter. So, that is anyway 1 meter cube. You don't have to do this as a separate step. You can do it with the next equation also. Then, what is the equation we have? Density equals mass over volume. Then, if we rearrange, mass is equal to density into volume. Now, here also students, you don't have to write both the equations. You can just write one of the two equations. You don't have to write this and then rearrange. Directly you can have this and substitute or you can have the second one and substitute. Either way is fine. Then, that is equal to 1000 kilogram per meter cube into 1 meter cube. So, you get the answer as 1000 kilogram. That is the mass of water contained in the tank. Because they have given the specifications of the tank, height 1 meter and the cross-sectional area 1 meter squared and the density and gravitational acceleration are given to us. So, we don't need to use gravitational acceleration here. Is that clear? So, with that, I'll move on to the next one. Here you can see what is the pressure exerted by water on the bottom of the tank when it is completely filled. So, pressure again, since this is water, we can calculate pressure using the equation for liquid pressure. What is that? Pressure equals H rho G. So, pressure equals H rho G. You all know the H, height was given to us 1 meter and rho 1000 kilogram per meter cube. And what is the gravitational acceleration? 10 meters per second square. So, then you will get the pressure as 10,000 Pascal. Is that clear? H rho G. 1000 is the density and gravitational acceleration 10 meters per second. The height of the water column is 1 meter. So, we get the pressure as 10,000 Pascal. This is one way of calculating pressure. Otherwise, what we can do is, now we already calculated the mass of water. Now, if you have the mass of water, you can calculate the weight of water. Now, weight of water is the force exerted on the area. That is the bottom of the tank. So, we need to find the pressure that is exerted by water on the bottom of the tank. So, to calculate that, we can also use the equation pressure equals force over area. So, we can use pressure equals force divided by area. So, here force is going to be mass into gravitational acceleration divided by area. So, that is going to be again mass, we found it as 1000 kilograms into gravitational acceleration 10 meters per second squared divided by area 1 meter square. Then you will get the answer as 10,000 Pascal. So, both are same. You will get the same value, but you can use one of the two methods. One thing, you can use the equation for liquid pressure, P equals H rho G, or else you can use the method where we calculate pressure as force over area. Is that clear, students? So, with that, I will move on to the next question. This is the third part of the question. The diagram shows a lever arrangement made to prevent the overflow of water entering the tank. When water gets filled, the buoy lifts, closing the valve, and the entry of water stops. So here, if you look at the diagram, this is an arrangement to prevent the overflow of water entering the tank. So here you can see there is the water inlet, then there is a valve. Here you can see this part. Now, if you look at this region carefully, students, here you can see the lever that is up. So there is space here, so the water can flow in. But when the lever or the valve comes down and blocks that opening, then of course there can be no water flow. So now the valve is open, water is flowing in. Then you can see here there is a lever rod and there is a pivoted point, so it holds the lever rod. The lever rod does not come off, but at this point, now this particular point you can see it is like a point of rotation. At this point the lever can rotate, it can move up and down around this particular point. Then the lever rod is connected to the buoy, that is like a spherical structure that is not very heavy, but it can move up and down. So at the moment, of course, it is supported by the lever rod and the mass of the buoy will be acting down. So that means the weight of the buoy will be acting downwards. So here the weight of it will be acting downwards. Then you can see there is a distance there. So you all know distance into weight or force. What is that? There is the moment of force. Moment of force. So here we have a point of rotation. There is a moment of force that can give rise to a clockwise rotation, and that is actually balanced by this particular valve. This side also there is a distance. So that can be rotated. So you can understand that. What will happen is now when the buoy moves down, the valve will go up. So the water can flow in. At the same time, if you can make the buoy to move up, now around this particular point of rotation, when the buoy moves up, this valve will be pulled downwards. That's how the rod will rotate like that. So the valve will move down. So then what happens? When there is water filling up, when it reaches this particular buoy, what will happen is it will start submerging in water. And when the buoy submerges in water, what will be exerted by water? Upthrust will be exerted by water on the buoy. Now it's only the weight acting downwards, then there will be upthrust. So when there is upthrust, there is a force acting upwards. Because of that, this particular buoy will be pushed up along with the lever rod. That is when there is a certain amount of water above this level, there should be more water. Then the buoy will move up and it will pull the valve down, so that this particular entrance will be blocked. The water inlet will be blocked and the filling of water will stop. Is that clear? So that is the water tank. Then we have the water outlet. Is that clear, students? That is how this functions. So there is moment of force. At the same time, there is the concept of flotation, where we consider the Archimedes principle, the upthrust exerted on the buoy by the water. Is that clear? So this is related to both flotation as well as the moment of force. So that is the introduction. Now we look at the questions. So again, the arrangement, the diagram and the question is given to us. First question, what is the force acting on the buoy at the position shown in the diagram? So I explained to you all, it is the weight of the buoy. Weight, or you can say weight of the buoy. Is that okay? So that is the answer. Then the next question, what is the extra force acting on the buoy from the time at which the water level rises and the buoy starts to submerge in water? So here, when the water level comes up to, let's say, somewhere here, then of course, there will be the upthrust exerted by water. So that is the answer for this question. Upthrust. So that is after the buoy gets submerged in water. Is that clear, student? So here you can see what is the extra force acting. So that is going to be the upthrust. I explained all that to you. Then the next part. State another advantage gained from this lever arrangement in addition to the prevention of overflow of water. So like I explained to you all, you can remember, when the water fills up to a certain level, there is upthrust exerted, so the buoy will move up. Therefore, the lever, this part will move up, the lever rod, and the valve will be pulled down. So it will block this entrance so that the filling of water will stop. So that means there will be no overflow of water. In addition to that, they want you to write the advantage. What is the advantage? There will be always a certain amount of water. The water level will be maintained. So the weight of water inside this tank will be a maximum value. It will not go above that. So that is one advantage you can write here. The level of water can be maintained within the tank. That is one. So that is one. The same thing. Now, when the amount of water inside the tank is the same value, then the pressure exerted by water on the tank also can be maintained. So you can write that as well. The pressure exerted by water on the tank can be maintained. And also you can say, now when this happens, the amount of water in the tank is always maintained. Therefore, the pressure exerted is also maintained. At the same time, every time you fill water into the tank, you will be filling only the same amount of water. So there is overflow prevented. So that means there is no water wastage. So it is an economical advantage. So here we can say it is economically advantageous because there is no wastage of water. Wastage of water. Now, in addition to this, you can also relate this to the amount that you need to pay for the water bill. Now, the water bill can be minimized, or there is an economical advantage because there will be no water wastage. Therefore, the water bill will not be too high. So, like that also you can relate it to this. So, you can write any one of these answers as the advantage. Is that clear, students? So, with that, I am going to end this chapter, and in the next chapter, I will discuss the last question with you.
To watch these important lessons, subscribe to DP Education's YouTube channel right now. Click on the bell icon to stay updated on the latest lessons. Sri Lanka's largest free online school, DP Education.